The previous section discussed the importance of integrating climate change adaptation and mitigation into urban planning. Section 5 discusses practical measures for urban climate change adaptation and mitigation with respect to key areas, including energy, water, green spaces, and housing. Concrete examples are given around the world to illustrate the measures. These will highlight the multitude of different ways climate change adaptation and mitigation is undertaken in urban areas. Low carbon development, use of renewable energy sources and taking energy efficiency measures are some examples of urban adaptation and mitigation in the context of energy. Renewable energy sources. The use of renewable energy sources such as wind energy lowers greenhouse gas emissions and therefore contributes to climate change mitigation. Energy efficiency measures. Energy efficiency measures such as light bulbs that use less energy or more energy efficient public transport are sometimes called the low-hanging fruit of mitigation because they are generally less costly than other options. Energy efficiency measures also have co-benefits. For example, better air quality from the lower emissions of energy efficient cars and buses. The case study on green lighting in Beijing in Section 1 is an example of an energy efficiency measure. Low carbon development. Low carbon development is generally taken to mean adopting low carbon development strategies. Definitions vary, but this would involve cities rethinking their development trajectories and taking a trajectory with lower emissions. The city of Sao Paulo entered into agreements with the Brazilian company Biogas. Biogas constructed facilities at 2 landfill sites for a total investment of $90 million. At the Bandeirantes site, a system captures the methane gas and channels it into a combined heat and power plant. The 2 landfills together now generate 10% of the city's electricity requirements. To date, the credits generated by reduced emissions have yielded some euros 48 million, with the city splits 50-50 with biogas. The City Council of Sao Paulo has used its share of the revenues to develop parks and squares in the poor neighborhoods surrounding these landfills. Climate change can affect water resources in many different ways. The rise of sea levels can lead to intrusion of saline water into urban coastal aquifers. Increased rainfall can decrease water quality, and droughts and decreased rainfall can lead to reduced water supplies. Climate resilient water management is important, as is strategic long-term planning. Climate concerns should be considered in water management plans, but also in other types of city plans. The water management plan could identify and address climate-related risks to water supplies, treatment and distribution, as well as identifying water conservation measures. Drought-prone areas can have drought management plans. Adaptation measures include water desalination from seawater, storing rainwater and reusing wastewater for other purposes, such as irrigation of parks. Water conservation is important, especially in drought-prone areas. This can be encouraged by measures such as water meters or by installing toilets that use less water. The photo shows Bus Rapid Transit, BRT, in Lahore, Pakistan. BRT operates its own lane, often making it a fast mode of public transport. Adaptation. Transport infrastructure can be vulnerable to extreme weather events, such as heavy rainfall or heat. For instance, roads and bridges can get flooded and damaged. Measures such as storm drainage or building roads in more elevated areas are examples of adaptation to such events. Mitigation. Transport is a significant emitter of greenhouse gases in cities. Investment in public transport networks and disincentives for the use of private vehicles, for example, congestion charges or taxes on vehicles, can reduce emissions from transport. Private vehicles and public transport can also be made more energy efficient, leading to lower levels of emissions. Other examples of mitigation measures include promoting car sharing and building bicycle lanes. The case study on the cable car transport network in Medellin in Section 1 is an example of mitigating emissions from the transport sector. Planning for green spaces in urban areas affects climate change adaptation and mitigation. Carbon sequestration is listed in the white cloud. Vegetation in cities can contribute to carbon sequestration. That is the removal of carbon from the atmosphere and its storage in carbon sinks, such as forests or oceans. Urban vegetation, such as trees, can store carbon. Urban agriculture, that is, farming in cities or nearby areas, also provides green spaces and carbon sequestration benefits. Green spaces can have numerous benefits relating to a wide range of issues, from cooling temperatures to important co-benefits. Green facades and roofs can cool buildings during the summer and provide insulation during the winter, reducing energy use. Trees also provide shade for buildings. Urban agriculture also reduces the urban heat island effect. Green roofs and green spaces can improve drainage of rainwater and thus reduce rainwater runoff in the case of extreme weather events. Planning for green spaces can have important co-benefits. For instance, trees can reduce air and noise pollution in cities. Public green areas such as parks improve the quality of life of urban dwellers and be an easily accessible public area for all. Urban agriculture can have a positive impact on food security and reduce urban poverty. This slide shows the UN Habitat publication Going Green, a handbook of sustainable housing practices in developing countries. The quote highlights the importance of housing and buildings in climate change mitigation and adaptation. Naturally, this is not only an important issue in developing countries. According to the handbook, this sector is a major user of the world's electricity supplies and has great potential for reducing its use. The way buildings are designed and constructed affects their energy needs and hence their levels of emissions. For instance, the design of the building can reduce the need for air conditioning or heating. Design and construction also impact on how buildings can withstand extreme weather events and other changes due to climate change. For instance, some materials and designs are cooler and thus better in areas with rising temperatures. Adaptation to extreme weather events, such as storms and floods, may involve using more robust materials or locating buildings at higher or more stable ground or on stilts. Sewage systems and stormwater runoff systems are also important. This quote from the UN Habitat Cities and Climate Change Initiative newsletter, March 2014, summarizes the importance of promoting compact urban development. For instance, urban sprawl increases distances people must travel and generates higher emissions. A more compact city makes investments in public transport infrastructure more viable. Urban sprawl also encroaches into the surrounding green areas that can act as carbon sinks. All options are correct, except for C. Bicycle pathways can be included on the sidewalks, which are considerably wide. This is one of the different strategies to encourage the use of bicycles. Only private cars can be seen in the image. At best, you can improve the public transport, making it reliable and efficient, so it encourages people giving up the excessive use of private cars. The roofs of buildings can be used for solar panels. Of course, there are many more measures that can be taken if we extend our imagination further from what can be seen in the image. What other measures could you suggest?